right, today we're going to think about stuff a little bit different, like it's going to move away from the patterns a little bit. And we're going to look at this figure. They've got these lines in your little workbook. This is on page 20. If I stop knocking stuff over, I can double check. That's the wrong one. Where did my workbook go? I don't know. It's okay. It's hiding. Nope, that's a spiral. I don't know where my crayon went. Oops, isn't that cool? There it is. And I found it. All right, so they've got these kind of lines on there. Yours are gray, mine are yellow, but it's the same kind of vibe. And what we're doing is we're gonna kind of mark out where we have some of these intervals. They've got some of these things labeled, like they're saying that this chunk is 1, that piece on the bar. So this is a length of 1. This is a length of something we don't know. That's a length of x. So if we're looking to mark out x plus 1, we can find a length of x and a length of 1 and add them together. That would be a mark of x plus 1. If I want to mark out 3x plus 1, I'm going to take 3 x's. I have 1x here, I have 1x here, and I have another x here, and 1, and we're going to add them together. Well, there happens to be a 1 right here. So that would be a length of 3x plus 1. Because we're just using this as kind of a guide. You don't have to put any of these little dashes that I do. This is just me trying to show you. Got tons of them. Okay, so when we're looking to do 3x plus 1s, where are we going to find that many pieces? I want to find x plus 1 3 times. So I've got, I'm going to do it on the slide. Ooh, that's not a highlighter. I've got x plus 1 right here, right? I've got another x plus 1 here because I have a piece of x and a piece of 1. And then here I have a piece of x and a piece of 1. So I have 1, 2, 3 x plus 1s. So are 3x plus 1 and 3x plus 1 equivalent? What do we think? Because this was 3x plus 1 and this is 3x plus 1s. Are they the same? Yeah. And this is really clear because they have the x's being really, really small. So we have like a third and a third and a third. They're really, really small. So the 3 pieces of x, 1, 2, 3 pieces of x, don't make it the same thing as 3 x's plus 3 1s. And that's what like all the space on the bottom is giving you space to write. Okay, so it's really looking at finding these equivalencies. That's what we're looking at here, is are they equivalent? And what we're going to do is we're going to use these kind of diagrams, and then we're going to talk about area a little bit. And I'll show you what to do with that on the dot page here in just a second. Because we're going to be talking about area and area models, which you have used before. You just probably didn't call them area models. Because what we're going to do is we're going to look at this dot page. And you have 3 dot pages because reasons. Oh no, you have 2 dot pages. Good, that's significantly better than when it used to be 4 dot pages and I cut lots of pages out of it. So what we're going to do is we are going to draw a rectangle on your page somewhere, probably kind of, not super tiny, don't do 1 box, but relatively small. Don't fill up the whole page, don't make it a single square, but just draw a rectangle. And you're going to put your corners, or the ends of your lines, directly on corners. So we're going to start with them directly on corners. And it's okay if ours are all different sizes. It's okay. Because for this first one, what you're going to do is we're going to figure out what the area is of our rectangle, which you have a few different options on. At this point, we could come through and count the boxes, but that's the long way. The easier way is to count our sides. Mine is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 9, 10, 11. Mine is 5 by 11. Yours may be different. Yours is probably different because the likelihood of us drawing a box the same size on a page this big is low. Put however big yours is. Count yours. I counted mine. So when I did mine, what is the area of my rectangle? Do you remember? How do we find area? Length times width. So my area here is going to be 5 times 11. Or my area is 55. If we know our 11s, which is great. If I don't know my 11s, I could do multiplication in parts. You remember that? Where we would bust it up into pieces. And I could do 5 times 10 plus 5 times 1. If I liked those numbers better and get 50 plus 5 to get 55. Multiplication in parts. There's a reason we used to do that in elementary school on how to multiply. Because especially when we're doing this and we're looking at lengths of sides where this is 10 and this inside one over here, this one's 1. It still is a number plus a number. It's still 10 plus 1. But it gives us that flexibility if I know one of the lengths, maybe we don't know the other one, to start working in some variables. Because next thing we're going to do is we're going to draw another rectangle on our page. I'm going to draw one down here. And this time I'm going to end not on a dot on both my walls. So I can't just count it up. I don't have the information. Maybe we measure and we find out that this one's still 5. This one, maybe we know this one's 4, but I don't know what this piece is. So could we find the area of this piece? What's the area of this piece going to be for me? 20. What's the area of this piece? Remember, length times width, so 5 times what? X. So we have 20 in this box and 5x in this box. So my area is 20 plus 5x. Or we could write it a different way. I could write it as 5 times, I do my length times my width before multiplying. 5 times my 4 and my x. These two pieces are equivalent. They mean the same dang thing. What it is distributed and undistributed. This and the fact that 4 plus x is length of this side is the basis for those area models that we used to use the box method when we'd multiply stuff. This is how the box method's born. These are baby box methods. Wow, it is dark outside. Like, it's gray out there. Okay, that's true even if we have things like variables the whole time. So let me... copy page. Let's see, can I make it do it? Come on, paste. Okay, not what I wanted, or not what I intended, but delete page. Ah! Paste. There we go. Okay. I'm going to use the space below, because what if we make another rectangle? You still need it? I still have it. Is that what the Okamon was? Okay. So, I'm going to draw yet another rectangle. Ooh, that's wonky. Let's try that again. This time, I don't know any of the sides. Maybe I know that this piece is 5. And this piece is 5. But I don't know this side. Let's call it X. And I don't know this side. We can call it Y. Because it's a different piece, I don't know that these connect. I don't know that they're the same, so I can't call them both X. So if they mean different things, we got to call them different pieces. We can still write this as an area. Our area is still our length, which is this piece combined with this piece. When we combine them together, we're going to add those. Our area we can write as x plus 5, and our width is 5 plus y. At this point, we're not going to multiply it out, but you could. Y'all have done this before. This is looking a whole lot more like our box method. When we multiply binomials in the box, or when we would factor quadratics in the box. This is where that was born, was rectangles that we cut into pieces. Pieces we know and pieces we don't know. This is where the box method came from. It's all about area models. It's a distribution style. Okay? There's a bunch of practice of that on page 97 and 98, where we can see these distribution problems. We can try them. We can look at them. All it is doing these kinds of area problems as distribution problems. Okay, it's the same thing. An area model is distribution. Distribution is the area model. Okay. So I want you guys to look at pages 97, or no, not 97. Sorry, I was looking at the wrong page numbers. 23 and 24. Significantly closer. 23 and 24. I was looking at my last year's notebook, which has the wrong year. Wrong pages. So look at pages 23 and 24. It's the exact same things that we just did on dot papers, but smaller. Find the area. Find the area of the pair. Write the expression. What is the length of the side? Okay, and it gives you some examples. So it's stuff that you know how to do. You've done that. You've done these things. You've done these distribution problems. You've done them for ages. Okay, so I want you to look at those and see those as expressions. See those as these kinds of problems. I'm not going to give you a separate homework on it, but I want you to look at those pages. Make sure you recognize how those get written sometimes. I'm not always going to give you homework on it. So look at 23 and 24, 25 if you want to, and make sure that you can see what's happening. I can see what's happening. I'm making very vintage references today. Lion King, that's an old one. I did Bring It On earlier. Lion King. Just busting some old school today. Elton John earlier. Like, my references have been very dated today. It's okay. It's a vibe. All right. So we have our first chapter test a week from tomorrow. I will get you a review next week. I will probably have it for you Tuesday, just so that you have a couple of days to work on it. We'll work through stuff together. We can practice some of these things. But it's really based mostly on the equivalent page. Like we did that. Are these two expressions equivalent? We'll do some of the pattern recognition stuff, like was on the homework 2, and some of the distribution stuff that we talked about today. Okay? How to distribute it, and then how to undistribute. Work backwards and find our factor. Those are all pieces you have done, but I encourage you to practice them. Look at pages 23 or 24, like the middle of it. Those are gonna look familiar. Okay? So look at those, practice with those. But y'all get to drive the boat on this a lot, bless you. All right, so you guys have 20 minutes. If you have not done homework 2, please do so. I believe there is, I think there is a third homework for this chapter that'll be next week, but you should have access to it now. Let me look. Oh yeah, homework 3 is more practice of this. It is some of the questions from these pages. So we'll talk about this more on Tuesday, and we'll practice more with these particular style. And then, so homework 3 you probably could do right now, if you remember how to do distribution. Okay? And that's the last homework for this chapter. We only have 3 in this chapter. So you guys, if you haven't done homework 1 or 2, I've gotten, I think, most of homework 1 in. Homework 2, I've gotten very few of them. So work on those now. They're on Canvas. I'll put that up here. 1.2, which is patterns. It's on Canvas. So work on that. If you have not done that yet, please do so. Ooh, my screen's going to turn off. Okay, so you guys have the rest of this time. This is kind of a pretty chill section of this course. Later in the semester, we'll have some more stuff that's a little bit more challenging, but this is pretty chill. Should be hopefully review. Hopefully remember stuff. I got a recycling over there if you want to use that. The one that has the circle hole.